I'm Anna, and I have tweeted the slides. I mean, there are too many slides here because I'm mostly going to be live coding. So yeah, who am I? I've been working on Node.js for a while now, and by now I'm working full-time on it at Neoform, which is an Irish Node.js consulting company. And well, if people know me for anything, it's mostly for putting workers into Node. Like, it wasn't all me, but I did a whole lot of the work. And some other cool things, like I was involved in HTTP2 in getting broadly support into Node, some other stuff. And currently I'm mostly involved in adding quick support for Node. I don't know if you've heard of that, but well, hopefully it's going to be cool, and we're going to need HTTP3 support in Node anyway. So, and so what I want to do today is to tell you a bit about how Node's internals work and what cool things you can do with them. So what I'm going to be doing is I'm going to re-implement setTimeout for Node.js. Like, that's a reasonably small feature that you can actually recreate on stage. And if you think about it, like, you might think of setTimeout as a part of the JavaScript language. It's like browsers have it, Node.js has it. Every other JavaScript runtime basically has setTimeout. But if you actually look into the JavaScript spec, there's no mention of it. And there's actually no mention of time passing at all, besides state.now returning like the current time. And why is that? And that is like, the concept of setTimeout is actually tied to the event loop itself. And the JavaScript language itself doesn't care about event loops or anything like that. So if you look at this example and you think about what happens, so there's one asynchronous operation that's happening, connecting a network socket and a setTimeout. And in an event loop-based system, there's always only one piece of code running at a time. So what the event loop actually has to do in this case has to be aware of both the timer and the network connect operation. And it has to figure out, OK, so if the timeout finishes first, so like if the connection takes more than 1 second to establish, I'm going to have to run the setTimeout first. If the network connection finishes after 200 milliseconds, it has to know, OK, this timer still needs to wait for 800 milliseconds. So it's going to have to figure that out. And that is the event loop. And in Node.js, the event loop is managed by something called libuv. It's the library we use for operating system abstraction and well, managing the event loop. So like some central concepts in libuv are, so there's two kinds of objects, basically. There's handles and there's requests. Handles are things like network sockets or file system watchers that actually emit multiple events over time. Like for network sockets, that would be incoming data, for example. And then there's requests, which are like, this is one thing that's happening, and that has one result, like file system operations, writing data to a stream, something like that. And so you might think that timers would be implemented as requests, because that's kind of what setTimeout does. It does something just once. But actually what libuv does is it uses handles because we use the same interface for both setInterval and setTimeout. And so setInterval is something that runs multiple times. So we're actually going to have to use a libuv handle here. So if you think about what actually happens when we schedule a timer, so we're going to have to store quite a bit of data. We're going to have to store the function that we're eventually going to call that was passed to setTimeout as an argument. We're going to have to store whatever data the event loop library needs. And so like, because libuv is a C library, we need a C or C++ wrapper object. If we want to access this object from JS, we need a JS wrapper object. And so something that we don't technically need, but that Node supports out of the box for everything it does, is async tracking. And I'm going to show you an example of how that works in Node, well, once we've finished coding setTimeout. I'm going to go through some internal helper classes that we have. They're just like something that, well, that makes some diagnostic tooling and some make some diagnostic tooling possible and take some of the work that we need to do. So first of all, there's a generic memory retainer interface in Node.js. So that's a class that we can inherit from, and that it enables us to say to, for example, the inspector when it's taking a heap snapshot, hey, this class has these properties, these fields, and they have these sizes in bytes. As a subclass of that, we have base object, which, I mean, these aren't actually JS classes. I'm just showing them as JS classes because that's easier to grasp and shorter and easier to put on a slide. So base object is something that we use when we associate a JS object with a C++ object and make sure like they have the same lifetime and everything. We have async wrap, which is the class that we commonly use for anything that performs async operations on its own. And so typically that's things that come from the event loop directly. And well, so a big feature of that is that it actually runs some hooks before and after a callback and when it's initialized and when it's destroyed. So you can actually keep track of everything that's happening in an asynchronous fashion in your application. And so one thing that we're going to use is that async wrap instances, they have this make callback function. And so when I started to get into, well, working on Node, and before that working on Node.js native add-ons, like there always was this thing called make callback. I was so confused by that, by the name and everything, because it doesn't make a callback. And it took me like a little year or two to understand that it's supposed to be, we make a call back into JavaScript from C++. I guess we're just stuck with the name because it's part of the public API, and we're not too keen on doing breaking changes to that, but yeah. So inheriting from async wrap, we have some helper classes that actually just take care of some things when we're talking about libuv handles. We have request wrap, which does something for requests, which we're not going to use, but it's there. And we're going to have handle wrap, and this is the thing that we're going to inherit our timeout class from. And so it also it comes with some built-in helper methods. I don't know if you've ever heard of that. Okay. I hope that wasn't the whole time there, right? No, good. So I don't know if you've ever seen ref or unref used in Node. It's not really something that the browser does because they don't really have a need for that. But ref and unref, so what ref does is it says, hey, this thing should keep the event loop alive. Unref does the exact opposite. So you can actually create a network socket, for example, and call .unref on that. And that just tells Node.js, hey, this thing doesn't need to keep the event loop alive. In the browser, you don't need that because like everything stays alive as long as the window is alive anyway. And when you close your window, you're going to close everything in it anyway. And this is kind of what I'm going to code now, or at least the JavaScript version of it. I'm going to write it in C++. I hope that this helps understanding a bit what this actually does. It's not a lot of code, as you can see. We're gonna initialize the timer with libuv. We're gonna start it. We're gonna give it a start function, and we're gonna use this callback from which we call this make callback. So we call back into JavaScript with a given method. And so one last thing that I'm going to be using and that you should be aware of or you definitely should be aware of when you're coding for Node.js is, so like all the public modules that you can actually require, like require HTTP or require zlib, they're actually in the lib folder in Node.js as plain JavaScript files. And so if you want to look at the source code for zlib, you actually just go to lib/zlib in the Node.js repository. We have some internal modules that you cannot require externally. The lib internal something.js. And we have the C++ modules that are also not publicly accessible unless you explicitly do that for testing. And they live in the source folder in Node.js. OK, and it's time to get started with live coding now. So I actually had the worker code open because I was just taking a look at that before the talk. So is that big enough for everyone? OK, I see people in the back nodding. That's a good sign. So I have opened the timers file. I could put this anywhere, but this seems like a logical place to put this. You can see there are some functions already in there, which is what we are currently using for setTimeout. And it's much more sophisticated than what I'm going to do. It's like people have put a lot of time into optimizing this, and it doesn't work the way that I'm going to show it. It did about like 2 or 3 years ago before we did all these optimizations. So one thing I'm going to do is I'm going to start with cheating. I'm going to copy some includes, which is basically the C++ version of imports, and so like this actually just adds a couple entries here and there. But if you want to do it from scratch, it takes some time to figure out, OK, I need these things, because it's not as beautiful as JavaScript, where you actually know which module is giving you which thing that you imported. And OK, so we're going to have a class timerWrap, which inherits from handleWrap. We're going to give it a timer property. This underscore at the end is just like internal style that we use for private properties. It needs a constructor, to which we pass the environment, which is in Node.js. That's kind of like a Node.js instance. So you could think of the main thread having a Node.js instance, like one environment, and every worker thread having an environment, and maybe embedders having some more environments that independently run JavaScript code. This is kind of like calling super but in C++. So this notation with the colon. And we're gonna have to do some tricks to tell the handle wrap. OK, so this is the handle that we're associating it with, like this dot timer basically. And so what I did here is I used provider timer as a name for the async wrap operation. And we actually have, I think here, we have a list of all the built-in async types. You can extend them with your own, but these are the ones that actually are available from C++. So I'm going to add a timer entry here. And so what do we want to do here? I might be forgetting things, but we're definitely going to want to initialize the timer and tell libUV, OK, so there's a new handle. I think this should be all that's necessary for that. So the next thing was we want to start method that takes a timeout argument. And because, so we're using V8 as a JavaScript engine, and we're using the V8 API to build C++ functions that are accessible from JavaScript as bindings. And they don't, like V8 doesn't really have a concept of JavaScript, of C++ objects. So we're actually, all the functions are kind of like regular functions that are not bound to classes or anything. So it's all static. And so what we actually do is we get this object called function callback info that contains all the information that we need, including like the value of this and all the arguments that the function received. And so there's some boilerplate that, no, sorry. I think this is right. Okay, I misspelled a sign. That's okay. So I'm gonna have to be cheating, just making sure that okay, assign or return unread. It's not a good name for what it does, but it essentially says okay, get from the this value whatever original JavaScript object with associated with it. And I copied this from the StatWasher code because it's actually very similar to what I'm doing here. And so after this, we have a handle to the original C++ timer wrap object that was created earlier. And we actually still need to get the timeout value that is supposed to be passed in as an argument. And we say, okay, this is definitely supposed to be a number. And this is actually just a very crude type check. So it's actually just going to crash if we don't pass in a number. And what we usually do to work around that is we do type checking in JavaScript to make sure that nobody passes anything into the C++ layer that's going to crash it. But for demo purposes, we can just skip type checking. So this is, again, just kind of what one has to do to figure out how to how to get a value from a JavaScript object into a C++ double in this case, so like basically just a number. So this is the point where I actually can tell the libuv library to start a timer with this timeout and no repeat. So if that first argument wasn't 0, it would actually start the repeating timer. We have to provide a callback for that. And again, and I'm just going to copy that again. We have some utilities too. So something that you could not do in JavaScript is, but what you can do in C++ is you can take a member of a class, like this timer field, and go back to the original object itself that contains it. Like that's just something that happens to be a big difference between JavaScript and C++, how objects are actually implemented. And so what we're going to do, we're going to do this make callback thing. And another thing that we usually do in Node.js, so when we know that we're going to use a string multiple times, we're actually going to look that up in a registry of a lot of strings that we're just going to reuse. And we create one instance of those per Node.js instance. So because that we do, because otherwise we always create a new string instance, or we would have to create a new string instance just to get the property of an object, for example. And that's kind of costly. We try to avoid that. I think I can just, I'm going to check with other code just to make sure I'm not getting it wrong. OK, so I can just say 0 arguments and null as the arguments array itself. And we're actually kind of close to having something that's working. So we have a start function. We have this timer wrap constructor. But again, V8 doesn't really understand C++ objects, so we still need to provide a function in the format that V8 can understand and create the timer wrap from inside there. And again, this is just something that's very boilerplatey. So I'm just going to copy it from elsewhere too. OK, so create a new timer wrap. There's no extra argument in this case. It's just the environment and the object that's supposed to hold the timer wrap in C++. And something else that we're going to need, otherwise this won't work, is we need functions that provide these memory info facilities that I mentioned earlier. And I know this is kind of dry right now, but we're almost done with the C++ part. So this is basically just, there is no extra memory associated with this. This doesn't hold on to other objects, just like this single class and nothing further. But it's actually going to enable us to look up timer wrap in the, for example, in an inspector heap dump and figure out if there are memory leaks with it or anything. And again, something else that I'm going to copy is this bit which actually tells V8. OK, so far we've only written a class and never used it anywhere. And I'm going to change that so that V8 actually is. OK, so these are the functions that you can use, which are basically timer wrap new and timer wrap start, which those are the ones we wrote in the format that V8 can understand, taking this function callback info thingy as an argument. And OK, so this string naming is inaccurate, but that should be OK. And I'm actually going to see if this works on the first try, which is, it hasn't done so far, but luckily it's just compiling Node.js right now. If you're actually starting with a fresh checkout of Node, it's also going to compile V8, and that's going to take longer than this talk. Because just like, I mean, Node is already a pretty big project, but when you look at the V8 source code, it's pretty standard to have files that are like a couple thousand lines and just like folders full of them. So I mean, the nice thing about C++ is that if I did something wrong, it's probably just going to yell at me as if I were writing TypeScript and got something wrong. And usually it's pretty easy to figure out what I did wrong. And also, just remember, so far we haven't, OK. Wait, I didn't change that file. Maybe I accidentally removed something here for some reason, which is annoying. But yeah, did anybody notice that? It's OK. That makes me feel better about myself. OK, sorry, this takes a while, so I'm actually going to jump ahead a bit and look into the public timers module that we have. And as you can see, like there's a whole bunch of code in there that just like it's very optimized. For example, we have these cases where, OK, so we look at the actual number of arguments passed to a function and do pretty trivial cases for that. So this wouldn't need to be this complicated if V8 could optimize this properly. And they're definitely getting there. Like they're aware that this is still faster than using, for example, spread arguments. But what we're actually going to do is, so I talked about this internal binding thing in the beginning, which gets us access to what was defined in C++ earlier. OK, it's still compiling. So I'm going to start with importing this thing that we just defined as timer wrap. And that should be exported to JavaScript now. Right. And so we're actually going to write a helper function that we would usually write in JavaScript around this original timer wrap thingy, which nobody is going to use. And we're going to make it look like the actual setTimeout function, which takes a callback function and a timeout in milliseconds and further arguments. We're going to create an instance of this. OK, I'm just going to call it wrap. I create an instance of the C++ class. And we're going to call start on it with the timeout argument. And so the callback, I called that on timeouts. So we're going to say on timeout. And inside the callback, so what we obviously need to do is to call the actual original callback function. And something else that, so for example, if I had more time, I would forget this on purpose to show you that this would actually be leaking memory, and we could see that in the inspector. Because I'm forgetting to close the libuv handle that was associated with the timer. And doing this actually releases the underlying C++ and C objects. OK, so this actually looks a bit better. Right, because I forgot to add return types to basically everything. Because I'm so used to writing JavaScript code. TypeScript? Actually, no. It's a pretty big gap of mine. As is the fact that I've never written anything in React or Vue or anything like that. So I mean, like these look like a lot of errors, but they're really just typos in the end, and that's pretty easy to fix, or at least it should be. So for example, forgetting semicolons, that happens. Oh yeah, right. So yeah, really just a lot of typos. I think this should be better. All right, and we can actually add this to the exports file, but to the timer module exports now. OK, I forgot to change this when I copy-pasted it. But there was only one error, so it really should be working now. I actually spent 3 hours this week just debugging a really dumb copy-pasting bug. And that wasn't JavaScript, and we don't use TypeScript, so nothing was telling us, hey, this isn't right. OK, so it's definitely compiling, and if I didn't do too much wrong, we should have a setTimeout function that's working now. And one thing that I could also have done is like not give this a separate name, but instead export it as the actual setTimeout that we use. And we could have run tests on that and see how much would fail. So required timers, it has this RuhrJS timeout function. And I'm going to say console.log hi. Oh, right. This is what I was talking about in terms of crashes. and it actually tells us, hey, this number thing that we were expecting is not a number, and I literally just forgot to pass it. So this is a bit worse. But it's also luckily I know what I've been doing wrong. And again, I've basically just been forgetting boilerplate code. What I did wrong is I actually forgot that. So like the callback that is called from libuv, because that is what takes care of the timers. But libuv manages the event loop, and the event loop is what's at the bottommost layer of the stack. So there's no JavaScript below it. And what we actually have to do is to tell the JavaScript engine V8, hey, get ready for executing JavaScript. And that includes setting up this handle scope thingy, which is basically telling V8, hey, we're going to create JavaScript objects now, or get access to them. And once we're out of this scope, you can garbage collect them. And the context scope is, that's more like getting ready to execute JavaScript. OK, let's try again. OK, that seems to work. And if I pass in a larger number. OK, so we have a working setTimeout. And if I can just, like, I think I started a bit late, right? I mean, I think I actually did. So I'm actually, I do want to show you how async tracking and how the inspector work and everything. I'm already going to start Chrome, because as much as I love Firefox, I don't think their DevTools supports this. And OK, so basically doing the same thing again, and not forgetting the timeout this time. I'm also going to copy some code, which is just debugging code. So like all of that is essentially just printing data from these async hooks that I was mentioning earlier to standard error. You might be wondering why, like, for printing to standard error, I'm not using console.error here. And the reason is that you can't do that when you're tracking async operations, because console.error writes to the Node.js screen process.standard_error, and that actually creates an async operation. And you can't create async operations while tracking async operations. I mean, you can do it, but it's a lot of work. Oh, right. So this is also why I shouldn't be using console.log here. Otherwise, we see these async operations. So we can see, OK, we're creating a timer. And after some time, we can see, hey, we're starting to do something with this timer, which has the ID 2. Then we're done with this timer. And finally, we're destroying the underlying object. And so if I give this a long timeout, enough to get the inspector attached. I don't know if you're using the Chrome inspector for inspecting Node.js, but it's pretty good. And I mean, it's the best profiling tool available, I would say. And so we're going to see, OK, there's a bunch of JavaScript objects that are just floating around. But what we actually should be able to see, and we're able to see, is, so there is this native C++ object, which holds on, for example, to our onTimeout function. And if you had a memory leak, that was because of this timer. For example, because I forget to close it and put it back into Node.js, or because you're just having a really long running timer and that holds on to other JavaScript objects, you could actually see, OK, if that's a lot of JavaScript objects, this number would be high, and you would be seeing this is a memory leak. And yeah, I'm sorry for maybe going a bit over. I don't know exactly how much this took, but yeah, I think that's about it.